it turns out that copper is the most dense because they all have the same volume, but their masses are different. And this plastic is more dense than the wood. All right, now where does water fit into this? Is water less dense than wood? Between wood and plastic? Between plastic and iron? I think we know it's not between copper and iron. So here's a quick demonstration that will help you determine where does the plastic fit into this density lineup. We'll take this bit of plastic here and we'll drop it in the water. And what does it do? It sinks right to the bottom. That means that the plastic is more dense than water, but we could tell that the wood would float on top of the water. Its density is much less than water. So water comes in right in between these. But how do we measure the density of water? Well, in order to do that, I took this block of clay and I inserted a cube in it, and it fits exactly the same volume. So this cube is exactly the same volume as all the other ones, and we poured 15 milliliters of water in there. So we could say that the water has a density of 1 gram per 1 cubic centimeter. But since it's a liquid, we don't use 1 cubic centimeter, we use 1 milliliter. A milliliter and a cubic centimeter are the same thing. Here's another way to demonstrate that. To reinforce the idea that 1 cubic centimeter is the same volume as 1 milliliter, I made a clay impression of a cube that's about 16 cubic centimeters. And we're taking 16 milliliters of water and we're filling it up. So we see that 16 cubic centimeters of solid is the same as 16 milliliters of liquid. So in conclusion, to find the density of an object, you have to know the mass, which comes from putting on a triple beam balance and finding the mass in grams. Then you have to find the volume. Most solid objects, you find the volume using a ruler and the formula of length times width times height. And that's how we calculate the density.